Okay, so let's work the warm-ups together. Can anyone tell me the standard form of a quadratic equation? And this goes for everyone in the room. Feel free. Who was that? Oh, John? Excellent. Yes, ax squared plus bx plus c. And because I said that's the standard form of a quadratic, plus c. But because I said equation, we want to make sure to set it equal to 0. Otherwise, it's a standard form quadratic expression. Okay, so it must be set equal to 0. You'll need to turn so you can see the screen. And there is an empty desk right there if you want to sit over there. Okay, so here's the important information about the standard form quadratic that you may need a refresher on. This term right here, A, is called the quadratic, I'll zoom in on this, quadratic coefficient. Okay, let me zoom in on this. Hang on a second. Give me just a second. Okay, so that A term is called the quadratic coefficient. The B term is called the linear coefficient. The C term has no variable, so we call that the constant term. So quadratic, linear, constant. Algebra 2 students, can you tell me the degree of all quadratic equations? 2. Degree 2. And the way we identify that for any polynomial expression or equation is by looking at the highest exponent in the equation. In this case, it's a 2, so it's a degree 2. Degree 2 equations indicate to you that there are 2 solutions to this equation. If it's real solutions, that means it will cross the x-axis exactly twice. If it was a degree 3 equation with real solutions, it would cross 3 times, etc. Now, let's perform FOIL. And we are going to use what we're now calling the De La Rosa method. You'll see what I mean. Michelle taught me this, and I like it. So now I teach it this way. First, outer, inner, last. We go first to first, outer to outer, inner to inner, and last to last. It makes like a crescent moon shape or a claw shape. Michelle called it the crescent moon, and I thought that was pretty cool. Just a note, I am going to take a grade on this for everyone in the room. So please, please just take notes and pay attention. All right, so here's how we solve this out. In Algebra 1, we do it step by step. In Algebra 2, guess what? You should still do it step by step. So the first terms are x times x. Put that in parentheses. Sorry, x times 2x. X times 2x in parentheses. Plus outer, which would be x times negative 7. Plus inner, which is 6 times 2x. Plus last, which is 6 times negative 7. Okay, so now we'll simplify and combine. So x times 2x is 2x squared. X times negative 7 is negative 7x. 6 times 2x is plus 12x. And 6 times negative 7 is negative 42. Does everyone agree? Okay, so all we have to do is combine these middle terms What is negative 7x plus 12x? Caitlin. Okay, positive 5x. Thanks for raising your hand. So 2x squared plus 5x minus 42. And of course, the whole time we should have been setting it equal to 0. So this is called the factored form that we started with. Okay, factored form. And for the Algebra 2 students, we want you to remember that that is f of x equals x minus p times x minus q. What are the solutions to this quadratic? Let me ask a different question. How would I take x plus 6 times 2x minus 7 equals 0 and find the solutions? What would I need to do? Just one step. So here's the good news. You're one step away from the goal line, all right? You have your factors. They're equal to 0. So each binomial equals 0. Solve little tiny problem. Let me show you what I mean. X plus 6 equals 0. Right? Minus 6 on both sides. So x equals negative 6. So the solution there was negative 6. Now over here, I've got 2x minus 7 equals 0. John, what would be the first step to solving this tiny little linear equation right here? 2x minus 7 equals 0. Add 7 on both sides. Thank you, sir. Mr. Rolando. Rolando, I have 2x equals 7. I want to get rid of the 2. Right now it's being multiplied by x. What should I do? Divide both sides by 2. Okay, so x equals 7 over 2. What is that as a decimal? 7 halves. 2 goes into 7 3 times with 1 as a remainder, so it's 3.5. Do we agree? Okay, how would I check that in the calculator? Here's what you do, guys. Here, let me clear the memory. 2 plus 7, 1, 2. Now, you think that the solutions, this is what you think. You think the solutions are negative 6 and 3.5. We call those solutions the zeros because if you evaluate the quadratic at those solutions, the output should be 0. So if I go to second window, change independent from auto to ask, then hit second graph, and I type in negative 6. Oh, okay, hold up. If I type in negative 6 and then, what was my other one, 3.5? Okay, there's nothing displayed now because I need to put something in y equals. We're going to put the standard form of our quadratic in y equals. So the standard form of the quadratic was right here. Okay, help me remember that. 2x squared plus 5x minus 42. Make sure I enter it right. 2x squared plus 5x minus 42. Okay, so now when I hit second graph, we should see 2 zeros. Do we? Please nod your heads. Yes. You understand this is why they're called zeros. If you graph this function, they cross at those zeros. So when quadratics have real solutions, they're the x-intercepts. If the solutions are imaginary, it will not cross the x-axis. It crosses on the imaginary complex axis. Okay. I feel like that was a good warm-up. We went ahead and did what I was going to do in number 3. Now, how to graph quadratics. It might seem ridiculous, but these are the steps, ladies and gentlemen. So we're going to go through some examples and do these steps. But first I want to highlight something. Last night we did a 3-hour and 4-minute live stream. There were 109 viewers. Peak concurrent viewership was 15 students, total watch time of 22 hours. That is a mad shout out to my freshmen. Thank you so much for joining that. If you had joined that live stream, you would have gotten 100% of your homework questions fully solved. Raise your hand if you were on it. There's no password to get on YouTube. Raise your hand if you were on the stream. Can you raise your hands up high? D and J? Okay. And Nick? Good. Good job, guys. We're doing it again tonight and every night until the STAR test, except for Fridays. Right. So, okay, so Monday. I'll do it again Monday. All right. Well, it's time for us to graph. So what we're going to be working from is this sheet. So now you're engaged on this sheet. This is your graded assignment right now. I've just got the information pasted from the CUDA worksheet into the OneNote. So we'll take our first one and we'll work it together. This is a simple quadratic because the leading coefficient is 1. Okay, number 1 from the CUDA worksheet. This is CUDA. Let's see, we have y equals x squared minus 8x plus 13. Okay, in my class, we always identify A, B, and C. Mr. Britton, what is A? Thank you, Tyreek. 1. Shin, what is B? -8. Pardon me. Carly, what is C? Thank you. Which one of these letters represents the y-intercept? 13. Okay, so C represents the y-intercept. Okay. Because the leading coefficient is 1, the master product is equal to C, because the master product of a quadratic is A times C. So a 1 times 13 is 13. The game we need to play, ladies and gentlemen, is something plus something equals B. What's B? I'm waiting. I want my Algebra 2 students to talk up. -8. Thank you very much. And something times something equals 13. Jerry, do you see a problem? That's right. 13 is prime. Who said that? Is that John? Thank you. So 13 is prime. There are no factors that will add to -8, regardless of the signs that they have. Do we agree? Okay, so when you exhaust this technique, what would be your next technique? You said it. I think you said it. What did you say? Oh. I thought you, because part of what, the Q, I heard the Q sound, I thought, because that's part of the answer. Q is the first letter of the first word of the answer. Yep. Quadratic what? Use the quadratic formula. Wait, Algebra 2, can you raise your hand if you've already learned completing the square? Have you learned completing the square? Maybe you did? Okay, you know what I'm going to do? For everybody in the room, we're going to do completing the square to solve this, okay? Because the quadratic formula is a mindless exercise. You plug it in and you get it out. The completing the square is a little bit more analytical. So it's going to be review or new information for everybody. So this technique is called completing the square. All right? So here's how you complete the square. Take your equation, x squared minus 8x plus 13, set it equal to 0. Now move the constant term to the right side of the equation. Minus 13 on both sides. Rewrite x squared minus 8x, and then leave some space and put equals negative 13. Okay, so I'm going to say what to do, and then I'll show what to do. We are going to square half the middle coefficient of the quadratic expression and add it to both sides of the equation. I'll say it again. We're going to square half the middle coefficient and add it to both sides of the equation. We're going to square half the middle coefficient and add it to both sides of the equation. So let's take half the middle coefficient first. There's the middle coefficient right here. Okay, so what's half of negative 8? What's negative 4 squared? All squares are positive. So half the middle coefficient is negative 4. Negative 4 squared is 16. So what we're going to do is add 16 to both sides. Now you have a perfect square binomial here with x minus 4 and x minus 4 equal to whatever negative 13 plus 16 is. What is that? 3? When you have two binomials that are identical, you can rewrite them like this. X minus 4 squared equals 3. Oh, this looks simple. Now, how would I get rid of the squared term? Thank you, Jerry. You know, 2 years ago, I'm going to tell you a Jerry story. She doesn't even know that I have this information in my head. 2 years ago, I was sitting in the lunchroom doing monitoring, and I was listening to Jerry, who I guess at the time was a freshman, explain like junior or senior level science or chemistry to another student. And I knew, I don't know that I'll ever be this student's teacher, but I knew Jerry was smart. Okay, so when you square root a square, you end up with the thing inside the radical, inside the parentheses. So x minus 4 equals the square root of 3. When you take the square root of a number, you always have to put plus, minus in front of it, like that. Now, how do I solve this? I got one step left. Yes. Yes, you don't have to ask. Yes. How do I solve this? One step. Just get x by itself. How do I do it? Plus 4. Thank you, John. Oh, Allie, you said that? Okay, good. Sorry, I was trying to make sure I engage my new folks here. So now here's your solution. Because you have a plus and a minus, it's telling you something. It's telling you there are two of me. There's x sub 1, which we say would be 4 plus square root 3, and x sub 2, which would be 4 minus square root 3. Okay, so these are real solutions. They're just irrational, all right, because square root 3 is an irrational number. So what we're going to do is use the graphing calculator here to just figure out what those are. 4 plus square root 3, and then I'll write it out to like 2 decimal places. Okay, that's 5.73. So we'll say that's approximately equal to 5.73. And then we have 4 minus the square root of 3. And that's approximately equal to 2.26. Or 2.27 if I round. Okay? So wrong thing. These would be your 2 solutions. These are your 2 x-intercepts. So we're going to create a little sketch here, just so we have some clue of what this thing looks like. Okay, so we have an xy coordinate plane. Nick, which axis do I label y? The vertical axis. So that must mean this is x. And remember, we call the x-axis the independent axis and the y-axis the vertical axis. The x is the domain. The y is the range. So I can plot 3 points right now. I can plot the y-intercept and both of the solutions. Okay, so we're just going to estimate where they would be. The y-intercept is at 13. So we'll just say that that's 13. And then we'll put our 2.27 solution here. And we'll put our 5.73 solution here. Okay. So let's sketch it. Is it upward sloping or downward sloping? That's because A is positive. So without knowing the coordinates of the vertex, which I don't want to find for this introductory problem, since it ended up being a hard problem with the completing the square, we're just going to sketch it in. You could estimate another reflected point there. Remember, you have an axis of symmetry halfway between the 2 points. So when you're trying to sketch your quadratic, dotting that in would really help. Okay? So it's going to look something like this, folks. Okay. Do my Algebra 2 students agree that that's about how it would look? We don't know the coordinates of the vertex, but it's going to be somewhere in Q4, quadrant 4. Okay. Looks great. Okay. Number 2. Actually, give me just one quick second to look at my key and make sure that we're going to get an easy one, because I actually want to take you through the whole thing. Okay, right now I want to ask the class, does anyone have any comments or questions about what's going on? Are you lost? Is this, well, let me ask Algebra 2. Did you guys already do this?
Yeah, not for one.
Now, John, I actually believe that you could probably do all these problems, okay? But I'm just get a general sense here. Don't say names or use any language just by hand raising. How many people could really have done that on their own? Okay, good. So that's good. All right, good. Yes, number 2 will work out just fine. Okay? So let's do number 2. Y equals x squared minus 4x. Okay, so first we're going to identify A, B, and C. A equals, B equals, C equals. Okay, let me ask my Algebra 1 students only to answer. What is A? 1. What's B? We haven't seen one like this. What's C? 0. Good intuition. C is 0. The y-intercept is 0. Okay? So, Let's factor this really quickly. We need two numbers that add to equal -4 and multiply to equal 0? Or what do we do here with this one? Here's one thing I want to remind everybody. Don't overthink these problems, okay? Yes. Excellent. Thank you. So Alyssa, you were correct. All right? But I was saying don't overthink the problem because I was concerned that because we have not done one where one of the factors was 0. Okay? So I just didn't want my kids to overthink it. What's that?
No, I mean the things that go in the blank. I mean 0 and -4.
Yes, 0 and -4. Okay? So when we factor this, we have x plus 0 and x minus 4. Algebra 2 students, was there an easier way to do this? See, this is when I was saying don't overthink it. And this is intuition that my Algebra 1 students, we're still trying to develop this intuition. But x squared minus 4x could simply have been factored using the GCF method, and you could have pulled out an x, right? So you could have rewritten it as x, open parentheses, x minus 4, and that equals 0. And so you have x equals 0 and x minus 4 equals 0. So your two solutions are x equals 4 and x equals 0. These are the x-intercepts of the quadratic. Yes, John? Yes, you could have used a perfect square. Okay. What would the perfect squares have been? No. Well, I'm asking you. So if it was x plus 2 times x minus 2, you would have a constant at the end because the L part would be 2 times -2. That last term would be -4. Okay. So don't overthink it. If you wanted to do using the perfect square method, your b would be 0 squared, which is kind of silly, right? So there was an easier way to do it would be this way, but it's good thinking. All right, so we have to compute something now that we know we can graph it. We have to compute the coordinates of the vertex. We know what the y-intercept is. The y-intercept 0. We know that our x solutions are at 0 and 4. So now we have to plot the vertex. Okay, Algebra 2 students, can you tell me the formula of the vertex? The x coordinate of the vertex. You guys remember this one? Were you taught this? Okay, this is frightening. All right. You knew it, Caitlin. Okay, good. Okay, good. So, Caitlin, can you help me fill it in? X equals -b. What's b? So, -4 over 2 times a. And what's a? 1. So, 4 over 2 equals 2. The x coordinate of the vertex is 2. This makes sense to us because if we have one x-intercept at 0 and one at 4, and we know that quadratics have an axis of symmetry halfway between the two intercepts, then it makes sense that it would be at 2. So how do I find the y-coordinate of the vertex now that I know the x-coordinate? Okay, let me tell you what we're going to do. We're going to evaluate our function at 2. Okay, so our original quadratic was x squared minus 4x. So what I'll do is open parentheses squared minus 4, open parentheses, close parentheses. And what we'll stick in there is 2. So f of 2 equals 2 squared, which is 4. And then negative 4 times 2 is negative 8. And 4 minus 8 equals... Thank you, Alyssa. Negative 4. So here's the coordinates I want to plot for the vertex. 2 comma, negative 4. Okay, so now I know everything. The coordinates of my y-intercept are 0, comma 0. The coordinates of the two solutions are at 0, comma 0 and 4, comma 0. My axis of symmetry is a line passing through x equals 2, right? My coordinates are at 2, comma negative 4. So this is an upward sloping line. You know everything you need to know. Make sure you draw it. I want you to go ahead and draw the quadratic, graph the quadratic. Give me just a sec. Hang on, give me just a sec. I'm going to pull this up. I'll pull this in. Let's make sure we can all do this. Hey, by the way, I want to tell everybody in this room, I'm very proud of you. You're behaving extremely well for a first period class with not so ideal circumstances, especially my students who are in a brand new environment. Thank you so much, guys. You're setting an example for these kids. I appreciate it. I have a huge bucket of candy here that I'm going to be handing out in a moment, and I'm going to let my Algebra 2 students take 2 pieces, okay? So let's go ahead and plot this. Let's get this plotted first, and we'll use our, just keep it together. Yo, we're almost done. We're going to end it here in a second, okay? This is our last problem. We're done after this, but let's just keep it together. Keep it together for about 90 seconds, please. In the back row on the left side. Keep it together for me, please. We're almost done. So I've got a coordinate here plotted at 0, comma 0. Where else do I plot on the x-axis? That's the axis of symmetry. We'll get to that in a second. Where's my other x-intercept? 4, comma 0. Thank you. Right here. What were the coordinates of my vertex? Thank you, Caitlin. 2, negative 4. So I go to 2 and go down to negative 4 right here. Okay. I have an axis of symmetry passing through the x-coordinate of the vertex. So passing through 2. Let me just make a note of that. It's kind of unnecessary and redundant for this problem, but sometimes it's really important. So now we can sketch, right? You need 3 points at least to sketch a quadratic. You got them. So let's sketch the quadratic. Caitlin, what do you think of that? Does that look okay? No, I don't like it. I want it to be symmetrical. It's really hard to do. Now it's too pointy. Whatever. Okay, candy time. Let me end the stream. Guys, I want to thank you. It was a really successful day from my perspective.